Okay, today I'd like to talk about the analysis of lung and heart sound using smartphone Stethoscope. Korea and the world population are suffering from heart and lung disease due to aging, especially thoracic sound has been widely known as a good method to detect chest disease. There are only few objective data regarding to bronchial or lung sounds. Therefore, it is necessary to normalize the data for breathing sounds objectively. In this paper, I like to show useful data for evaluating the chest sound by applying PCA and AVR-LCR to breathing sound data and then present unobjective data about asthma and pneumonia. There are many subjective opinions of doctors in diagnosing heart and pulmonary disease with the Stethoscope. However, the smart Stethoscope proposed here displays heart and pulmonary disease as waveforms and spectrograms to provide objective diagnosis. Use of auscultation in pulmonary medicine has not theoretically been developed yet. So it calls for the quantitative analysis of the breath sound. But thoracic sound has shown to differ according to circumstance and despite of same patients. The purpose of this study was to classify normal person and patients who has pneumonia. Diagnosis was made using the smart Stethoscope and characteristics of diseases was confirmed by PCA and AVR-LCR algorithm. A block diagram of the pneumonia data extraction system is shown in Figure 1. Thoracic sounds are acquired on the chest by air-coupled microphones. The signal input to the sensor is sent to the preamplifier and the high-gain amplifier and is then sent to low-pass filter and an envelope extractor circuit to extract the characteristics of pneumonia. The envelope extractor consists of an absolute value amplifier, a peak detector circuit, and a sample and hold amplifier. The peak detector acquires the maximum amplitude of the pneumonia absolute value during the sampling period. The peak value is transferred to the SH and the peak detector is then reset. A sequence generates the required control signals from a distally controlled clock. The system is based on smartphone with the data acquisition boards. The board has one channel analog inputs, which are sequentially digitized with 12-bit solution during the sample period. The board also has digital I/O ports, which are used to control the clock frequency and the gain of the amplifiers. The digitized signals are transferred by I2C ports to the memory and finally stored on the hard disk. 10 records were performed by each disease with an acquisition time of 1 minute, 5 positions. Left, right, center lung, and back left and right low, and a sampling rate of 2 kilohertz per input at Jesus Hospital in Jeonju City. Figure 3 shows normalizations data of 10 thoracic sound sets by each asthma, bronchial patients. To obtain first vector value of PCA, we apply a simulation through software program. As a result, the original thoracic sound vector values are shown in Table 1. In the experiment for thoracic sounds, the structure of hardware system and design with programming are introduced. This paper proposed characteristics thoracic sound to use PCA and AVR-LCR for objective data for thoracic sound. Table 1 through Figure 11 are shown various data for each disease, which are detected as the useful thoracic sound data in diagnosis. respiratory physicians evaluated the detected thoracic data as useful, and we have attained a result of a feature that can determine the disease. Considering the above result, it is necessary to study for more accurate hardware, structure, and software thoracic sound of the system. Also, more reference DB for solving the reliable thoracic sound algorithm have to be designed for a perfect hardware system. We are going to analyze the constraint conditions and various distortion of the hardware for more useful design. Thank you.
네,